So today we're going to talk about combinations and permutations, okay? Specifically, we're going to talk, permutations and permutations. This is unit 5.2, okay? We're breaking it into two subunits, 5.2.1 and 5.2.2. We're going to talk about 5.2 in this video, and then in the other video, we'll talk about 5.2. Okay, but first, let's just go over some general vocab for the overall unit. It'll help you understand the language I'll be using. Okay, so first things first. Okay, the outcome is the result of the experiment or event. Okay, the permutation is a way to find the number of outcomes where order does matter. Okay? Whereas combination is a way to find the number of outcomes where order does not matter. Okay, so that's the difference between a permutation and a combination. One funny note of trivia is that when you ask for the combination of the lock, that's actually not the correct language. You should ask for the permutation. Why? Because the order of the numbers matters to unlocking the lock. If you ask for the combination, they could tell you the numbers in any random sort. So let's say the combination is 5, 1, 2, 3. If I ask for it, right? But if I ask for the combination, you could say, oh, they're 1, 2, 3, 4. But it's not the right order. But I gave you the numbers. Okay? So be careful. The language here really starts to come into play. Okay? Now, factorial is kind of a new thing for you guys. This is the product of a number and all numbers below it, i.e., if you have 5, that's actually 5 times 4 times 3 times 2 times 1. All right? So let's go and move now into talking about permutations, which is one we're going to focus on today. All right, next page over. Now, permutations, again, is where the order matters, right? There are two things to keep in mind here. N is the number of things to choose from, and R is how many things you choose out of that set. This is basically your sample space. This is basically the number of chosen items. For example, on this first one down here, for repetitions allowed, N is the total sample space. And R is the number of chosen items. Okay? All right. Now, let's take a look at an example of this. In this first one here, we have how many different ways can you arrange the numbers for a lock that takes 4 numbers? Okay, well, we have numbers for a lock, and we have 4 numbers. Now, this right here is your N value. Okay? And it's going to be equal to 10 because, i.e., we're looking at digits, right? Which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, we're looking at the digits, basically. Okay? Now, that means over here, this is R equal to 4. Okay? That means we're going to have 10 permutated over 4. That's how we say the equation, basically. All right? All right, so that means that we're going to do 10 to the 4th power, 10 n to R, and that's going to give me 10,000. Okay, so on this lock, if I only have 4 digits selected, those zeros are pretty bad. Let me rewrite that. Okay, if I have 4 possible answers for each of the parts of the lock, and I'm only going to, if I have a 10-digit combination lock, and I'm only going to use 4 of the digits, that's how many different ways I can set up my lock. 10,000 different ways. So, moving on now. So now, but what if repetition is allowed? What if we can only use a digit a certain amount of time or only once? Like 1, 2, 3, 4, I can only use 1 once, right? After that, I can't use them again. I can't go 1, 1, 2, 3, 4. So what you need to remember here is that, let's take a look at an example, basically, to understand in depth what's going on. All right. First of all, there are 8 people, all right, running a race. How many different ways can first, second, and third place winners be arranged? Okay. So this right here is my R value. Oops. Okay. This right here. Hang on. Bump my papers and they're all out of order. Fix the camera. There we go. Okay. This right here is my N value. Okay. Which means that I now have 8 permutated. That was not right, the color. Oops. Why do I keep putting this up? Just take it out and leave it out. There we go. Okay. So it's going to be 8 permutated over 3, which means we're going to plug it into this equation. So we have 8 factorial over 8 minus 3 factorial. That gives me 8 factorial over 5. Now, there are 3 ways to really solve this at this point. There's a calculator way, another calculator way, and finally, algebraically. Not algebraic, sorry. Arithmetically. That's what I was looking for, which basically just, combination of numbers being added or multiplied together. Now, again, a factorial of 8 would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? The other one would be 5 times 4 times 3 times 2 times 1. And I can cancel the common numbers in the fraction here. The 1's cancel, the 2's cancel, the 3's cancel, the 4's cancel, and the 5's cancel. All I'm left with is 8, 7, and 6. So now I have 8 times 7 times 6, which gives me 336. Now, that's all well and good, but that took too long. There's a faster way to do it. All right. Now, in the calculator, I get the same answer by doing 2 different ways of solving. I'm going to show you the fraction version. I'm going to show you the super fast version. The fraction version uses the factorial symbol. You'll notice in the calculator, there is no factorial exclamation point on the keyboard or under any of the modifiers for shift and alpha. There isn't. There's no shortcut. You have to look it up in the data tables inside the calculator. Okay, or the operations, I should say. Sorry. So we're going to do 8. Sorry, we're going to first of all, we're going to put parentheses of 8, because in order to fraction the calculator, we got to put the top and the bottom in parentheses, right? So everything that's on the numerator goes in parentheses. Everything on the bottom goes in the parentheses. So we've got 8. Go to math, probability. Whoops. I messed up. Math, probability, or PRB. And you go down to, hey, look, there's the exclamation point. Let's grab them. Then you close it up. You divide. Repeat for the bottom. In this case, it would just be 5. Math. Go to probability. Get an exclamation point. Close it up. Enter. And there's your answer. Math, PRB, right there. Yep. Okay. Now, but there's even a faster way to do this. Okay. If you type in 8 first and go back to math, go back to probability, you'll notice, hey, that looks familiar. Oops. Okay. They're the same thing, guys. You can use the calculator option so long as repetition is not allowed. If it is allowed, don't use the calculator NPR, okay? You have to do it with the number to the power, which is just easy. It's just, yes, just like, to the 4th power, 5th power, whatever it is, right?
So would it be 8 minus 3 for the denominator? What the factorial?
Yeah, so it'd be 8 minus 3 if you were going to do it like that. But here, if you're going to do the shortcut, you would actually just type 3 in, because we're looking for R. R was 3 right here, first, second, and third place. Hit enter, you get 336, and there's your answer. Now, something else that's going to come up later on when we talk about combinations, but I'm going to mention here as well, and in both sections, but here for now, is here's the thing. The reason why this repetition is not allowed, though, is it didn't really tell us. So what was the defining factor? People. You can't use the same person twice. You can't in placement. Okay? I can't have person in first and second place. Golf doesn't even do that. If you ever have seen a golf game, if you have somebody tied for first, they play on till that other person drops a shot. And then it's over. Okay? So you could say that the game of golf is essentially a permutation that does not allow repetition, which is pretty much what it is. Okay? So that's how you would discern between the two. You have to kind of look at what you are permutating. People, cars, combinations. Those objects will tell you and how you're permutating them. Are you placing them in a roster? Are you using them as a code? Are you know what I'm saying? So you have to read into all elements of the question. Okay? Let's go ahead and look at some examples. Oh, and real quick, actually, for those of you curious, one more thing I want to mention here is in the calculator. Okay, here is the operation on how to get there. It's math, and then PRB, and then it's either going to be option. It'll be option either 2 or 4. So it'll be either 2 NPR or 4 exclamation point. So if you need to have two options, I know that's really small. I apologize. There will be a scan of this up online if you need to see it if you're here in person. But for those of you at home, you should be able to kind of zoom in on that and see it, okay? Plus, it'll be bigger on your screens. All right, now let's go and look at some examples. Okay? All right, so let's take a look at an example here. How many ways can the letters in the word Maine be arranged if you use all 5 letters? And repetition is allowed. Great. That means we're using the first equation. N permeated over R equals N to the R power, right? So we're going to do, so N repetition is allowed, okay? And we're looking at how many letters can the word Maine be arranged if you use all 5 letters? And repetition is allowed, okay? So we're going to do 5 is permutated over 5, which is 5 to the 5th power, which is 3,125. Okay, very easy, straightforward. That's the bare bones basic problem you're going to see. All right. I'm going to straighten my papers again. Hold on. Come on. Thank you. All right, let me get it up here so that way I don't have to keep shuffling around. All right. So, number 2. How many different 3-digit codes? Okay. Let me get my underlined color here. 3 different 3-digit codes can you make with a single-digit whole number? Or single-digit whole numbers. So this is back to digits 0 through 9, okay? Without repeating. So our defining factor down here is without repeating. We know that this is going to be N. We know this is going to be R. And it's talking about digits. So that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Those are my digits. There are a total of 10 of them. Okay? So N is going to be equal to 10, which means we're not repeating. So we're going to use the second equation. So we're going to do, oops, not that. We're going to do 10 permutated over 3, which equals 10 exclamation point over 10 minus 3 exclamation point equals 10 exclamation point over 7 exclamation point, which then equals 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. Okay. 7 times 6 times 5 times 4 times 3 times 2 times 1. Cross out 2's in common. And you're left with 10 times 9 times 8, which equals 720. Now, if you wanted to plug that in the calculator, you could. So we could do 10 math prob permutated over 3, because 3-digit code. Enter, and there it is, 720. Whoops, sorry. There we go. All right. The next one. How many ways can 3 people win first, second, or third place? Again, people. This is not repeating, right? We have a roster. So we're looking at 3 people and we're looking at first, second, and third place. That means that's going to be my N. This is going to be my R. Now, something you should note. Back up here, there's a note here that says, if N and R are the same number, you can use N factorial. Now, that is a great shortcut, but why do we have that shortcut? I'm going to show you. So on this problem, that means, let's just plug in the equation and see what happens. We have 3 permutated over 3. So we're going to have 3 factorial over 3 minus 3 factorial. That gives us 3 factorial over 0 factorial. What? Can you divide by 0? No, but there's an answer here. Here's why. 0 factorial is equivalent to 1. Much like how any number to the 0 power is 1, this is a mathematical law. There's a very large, complicated explanation and proof behind it that we're not going to get into in this video. But for right now, and all intents and purposes, that's all you need to know is that 0 factorial equals 1. Okay? And anything divided by 1 is itself. 3 factorial will be 3 times 2 times 1, which gives me 6 as my answer. So when you have a number where basically you have the same sample space and the same how many things you can choose, you should be grinning ear to ear. Just factorial the number and run with it. That's a gimme. All right? Last one, how many ways can 8 students sit in 4 seats? This is people again, guys. It is not repeating. Repetition is not allowed. Okay? So there are 8 students, 4 seats. We have N, we have R. All right? So we're going to have 8 permutated over 4 equals 8 factorial. And we have 8 minus 4 factorial. That gives me 8 factorial over 4 factorial, which equals 1,680 if you were to plug in the calculator or list it out. But I'm going to skip that for right now because I think you guys kind of get the idea of where this is going and how to do these. All right? Make sure you do your homework. Good luck.